parties. You need a second pair of eyes to look at security systems. Don't rely on internal teams to do it. There are companies that do an astounding job of internal analysis of their applications before they release them. Great example of this, Microsoft and the security development lifecycle. Profoundly excellent teams, profoundly excellent culture of shipping security software, of secure software. That's something that only happened in the last 7 years or so. They're excellent at it. Microsoft relies heavily on third parties to look at that stuff. We were one of the companies that looked at Vista. We had firsthand experience looking at the process of third parties looking at stuff. It is effective. It works. People should be doing it in general. We had hoped that extrusion detection products, being security products, would have had that done. Next slide. I think a lot of people are coming to this talk expecting us to talk about evading extrusion detection systems and how to get sensitive data past an extrusion detection system. Let me say this. We'll talk about evading extrusion detection systems, but we're not going to focus on it for the simple reason that you can take it as a given that these systems are evadable. This is a fundamental problem with computer science. There's no good solution for how you would deal with sensitive data encoded in a variety of different formats and intentionally obscured, or obviously encryption is a problem. There's just a variety of different ways to sneak data past. We'll talk about it. But that's not why you should be concerned about these systems. The reason you should be concerned about these systems is that by deploying them on your network, you potentially expose yourself to very serious, very real vulnerabilities that can impact the security of your network. So we're talking about things like the installation of these systems could compromise the sensitive information that you are trying to detect. We'll give you a scenario in this talk where it's possible that a system could do that. We're talking about endpoint systems which are installed homogeneously across your network on thousands of different endpoints, bearing and supporting vulnerabilities that would allow me to take over thousands of machines on your network and tell them to do whatever I want. We're talking about vulnerabilities that would allow people to take over the management consoles, that in turn control the behavior of all the extrusion detection systems and the boxes they're deployed on across the whole network. We're talking about very real vulnerabilities here. This is not a theoretical talk on how you would slip data past an extrusion prevention system. So we saw systems that were relatively impressive. Like we said, nothing got out unscathed. We saw some systems that had paid pretty close attention to these problems. We saw systems where the security of the deployment environment was clearly not a particularly important security goal. You can there are keywords you'll get from vendors that'll kind of allow you to infer whether that's the case. They'll say things like, well, this product isn't necessarily designed to be secured from or to resist attacks from internal people. It's really, it's designed to detect things, but not necessarily to be resistant to internal attackers. Fine, whatever, I don't care. The issue is if you install stuff on every machine in your network, it had better be secure, and we'll talk more about that as well. Some of you, at least one of you in the audience was at a talk that we gave last year about pretty much the same issue. We're going to try not to touch too much on the material from last year's talk, but it applies here as well. So one of the things that we hope you can get out of this talk, as we talk more and more and more and more, is there are better systems that you can choose and there are worse systems that you can choose. And I hope that you guys will make the security of the deployment itself and the security of the product and the reliability and integrity of the software you deploy a major component of your decision-making criteria, not just how convenient it is to, administer and whether you like the user interface and whether or not it's cross-platform and works everywhere and what the functional matrix is, but also whether or not, just deploying this on your network is going to root your whole network. I'm going to say, go out on a limb and say that's a little bit more important. Here's the slide where you all get to groan and throw things at me. If you guys have things on your desk, you're now welcome to throw them in. Whoever in the audience is going to write the blog post accusing us of selling out for not naming names, please raise your hand. I'm going to thank you after the talk. I'll say, for a variety of reasons, the talk that we're giving, this is like rule number one of presenting in front of people is don't apologize for the talk you're going to give. And I think I have an unbroken track record of breaking that rule in every talk I've ever given. And breaking it now, I'm going to apologize in advance. The talk that we're going to give you right now is not the same talk that we had intended to give you when we originally submitted this talk to BlackHat. There are let's just say that we're going to be careful about the information that we provide in this talk. Montesano, along with a couple of other security consultancies or security services companies, has a code of ethics. And I'm saying this not because I'm super proud that we came up with the idea of a code of ethics, but as a way of encouraging other security companies to do this. It takes 10 minutes to get the partners in your company together and agree on something. And in our code of ethics, we will not release vulnerability information, detailed information about vulnerabilities before patches are issued. That's not necessarily the right thing for everybody to do. There are circumstances where it's a good thing to release things before patches are available. We don't do it. Another thing that we don't do is, for us, NDAs and client commitments are ironclad, and both of those situations applied here. We had hoped by the time we gave this talk that a lot of the vulnerabilities that we were talking about in extrusion detection systems would be old news, would be resolved, and we could talk about them in some great detail. That is not the case. So, I'm going to rationalize for you guys right now. It's not going to be totally convincing, but I'm going to rationalize and say that you don't care about the specific vulnerabilities. You're not going to use them. You're not going to plug them into Metasploit and, break into networks based on the vulnerabilities that we found on these products. What you want to know are the patterns that we use to find the vulnerabilities. And we want to arm you with questions and patterns and things to look at, even in systems that we didn't necessarily look at. So we're hoping that this is, it's less sexy, but it's, more useful maybe. I don't even necessarily believe that rationalization, but it's the rationalization I am giving you. However, in order to make this, or attempt to make this an interesting talk, we are trying something a little bit different, and I will let Eric introduce the thing that we are trying to do to compensate for that.
I'd like to introduce PlugBoy. This is a cutting-edge, imaginary extrusion detection product from the mines at Montesano. Of course, this is an agent-based detection solution, version 0.6.6.6. Did I give an extra 6 there? Yeah. Anyhow, I'd like to kind of elaborate a little bit on what Tom just talked about too. That yes, there's going to be stuff in this talk that may seem like it's really fake. Obviously, this is a little fake looking. But I think what we're trying to do here is give you the framework in which to take away from this talk some ideas, some methodologies, and like Tom said, what to look for and what not to look for in the products. Do you want to add anything else here?
The idea for this comes from, obviously some of you guys in the audience will be web app pen testers. The idea for this is from WebGoat, which is the OWASP punching bag application, which they use to demonstrate all the vulnerabilities. We didn't have time to actually implement the WebGoat of extrusion detection systems. I'll also say that at this point in history, the WebGoat of intrusion or of extrusion detection systems is almost any extrusion detection system that you would buy. So the idea here is, an artificial system that would allow us to kind of elaborate on the specific details. And since we've been talking for like 20 minutes now in intro, I'm sure you guys are aching to get to actual technical detail. I know I would at this point, so we'll get into it. So we're going to start by kind of describing to you guys what, I can't even say the word PlugBoy without laughing, but we're going to start by explaining to you, or Eric's going to give you a guided tour of the architecture of the PlugBoy extrusion detection system.
Okay, so yeah, enough apologies. Let's get on to the good stuff. Okay, so this is more or less what our PlugBoy architecture looks like. And I want to just to take the step back and remind everybody that we're talking about the hypothetical here. There's a good reason for this design. It's meant to be kind of general, and you're likely to see that these sorts of architectural components are pretty common amongst agent-based extrusion detection systems, and it even, in a lot of cases, applies pretty closely, except for a couple of boxes, maybe, to your average agent-based security product or agent-based product at all in the network. So obviously you have your server and your agent. In this case, we've got bidirectional stuff going on from the server to the agent, agent to server. That's important to bear in mind that in most cases, well, it's hard to say in most cases. You can go one of two ways with an agent-based solution. It can be server-initiated to the client for the monitoring, or agent to server. PlugBoy is agent to server. The components on the agent we're going to get into a little bit more, so I'm just going to go cover the server a little bit more here because we're probably going to come back to it a little bit more later. So you'll have your pretty standard components like the administration console, detection policies, which are the configurations basically for extrusion, report databases, which is where your alerts and extrusion events occur or are recorded, and as Tom mentioned, as we touched on earlier, the unique aspect to extrusion detection, I think somewhat unique at least, is the forensics store. And we'll be talking a little bit about definitions of forensics and so on. And then, of course, I'll go through the agent as well here. The flow here is important to bear in mind, and we're going to be following the same flow as we talk about these pieces. The first piece is your data intercept engine. That's kind of a fancy word for the monitoring piece of this product. The thing that sits there, well, actually, no, intercept is a better word. This is sitting there at the endpoints of I/O on the agent, your network cards, your USB drivers. It could even be in the applications. But the commonality here is that this is the piece that intercepts and grabs data so that it can be inspected for extrusion events. The piece that actually does the detection is your detection engine. We'll be talking pretty detailed about what kind of technologies that go on there, though, so I'm just going to keep on going. Then, if something is flagged as a extrusion event, it'll get passed to the reporting agent, which in turn passes it to the server. So we'll be talking about these pieces. And the other piece there, too, that's very important, obviously, is the forensic data. And like I said, we'll be talking about that. Just bear in mind that forensic data originates on the agent, so it's pretty unique from a security standpoint. You'll see why. You probably can already imagine some ways, but we'll be talking more about that.
So when you're looking at this diagram, and I apologize for the people in the back, it's hard to read. But when you look at the diagram, this is just a basic methodology thing. When you're looking at a brand new application, try and figure out the subsystems that are involved, how they communicate, and how they interact with each other, how they couple to each other. What you have here is basically a breakdown that you can look at and start asking questions about the individual components and do a pen and paper application penetration test of the system. Just coming up with questions to ask your vendor about, how does the reported events that come from the agents, how do they make it to the server, and how does that channel actually work? How do you actually intercept information? How do you know if somebody put a credit card number into a Word document or whatever? So we want to make sure you understand that our approach to this was to break it down into its subsystem level components. And then these are the ones that were general to all of the systems that, all of the agent-based systems that we looked at here. And then, like we said, the talk is going to basically follow these components as we kind of look at each one of them in detail and tell you what can go wrong with them and what you should be asking about them.
One more thing about the generalities. I want to also emphasize that what we have here, it's broken out for plug boy. In this form of breakout, these pieces may be incorporated in different ways, but they will always be there, so just bear them in mind. Okay, so the plug boy agent, as I said, I was going to get into, and we're going to be talking about these architectural components in the context of plug boy, and then talk about the vulnerabilities that we can expose in plug boy, and we're going to be talking about the context of how that can be applied into methodologies. So Plugboy is installed everywhere in the enterprise on every workstation. So by everywhere, I mean it has to be installed on everyone's workstation. It's another tray icon background service. It can be a number of different implementations. For the purposes of Plugboy, this is a tray icon and a background service. So, and there's probably a little, was there a kernel component? Okay, there's a kernel component too. What it's doing, as I think I touched on a little bit, was data interception. It's covering all of the bases that we just talked about, so I'm not going to repeat them. Of course, it's also doing the forensic interception, which we'll get into more as well, as I said.
So here's the point at which people that saw my last talk can go to sleep for a couple of minutes. We talked about this last year. We gave a talk last year about endpoint agents, not in the context of extrusion detection, but more along the lines of software update, patch management, system integrity monitoring, things like that. The conclusion that we drew after another research